My name is Ron Deavers. I'm a software engineer with the Raycore division of Parker Hannifin. I'm going to discuss our current process of implementing EMI at our facility. And in these stages, I'm going to talk about our challenge to cut warranty costs and to make data available in a timely manner. And, in a garage, just like our big, great companies like IBM. Our products include fuel filter water separators, high flow filter vessels, oil filter systems, automatic transmission filters, engine air filters, crankcase ventilation filter systems, and many more customized OEM solutions. Our filters have met the needs of many, many markets, including on-highway, off-highway, marine, agriculture, and stationary power markets. Our current customers include Daimler Chrysler, International Truck and Engine, John Deere, and Isuzu. The first challenge I'd like to speak about is parts that were leaving our facility, sometimes with incorrect components on them. This happened for a various number of reasons. Our assembly cells consist of modular tables. So when something went wrong, they were able to replace one table and replace it with another. That was one reason we would have issues. Another issue would be some of the similarities in our components would include just the change of a filter type. So the only difference the operator would see is a part number, and sometimes that can get confusing. So that makes it easier for products to get mixed together and causing parts to get put on the wrong units. Another challenge we faced was there was a lot of time spent on documentation. Our operators do a lot of documentation. These are just three, right here I'm mentioning three documents that they do on a daily basis, per line, per shift. There's an end of the shift report, takes 20 minutes. This tells what errors went on in the cell and what they did to fix it. The inspection report, every 2 hours, slows down the line once every 2 hours, and it takes about 15 minutes. And the hourly report, where they log how many parts they built and how close they came to their goal, that's about 10 minutes per day. And so with at least 45 minutes per day per cell, over $100 is wasted. So the solution for the incorrect components is twofold. We decided to do a SCADA system on our cells. The first portion was the Supervisor Control. We decided to put labels on all our parts, serialized labels, to follow them throughout the cell. So the labels are generated before the run and placed on every part. And this tells the cell, okay, this is what part's being ran, and this is the processes to go through. It also is verified at each station. So each station has tells the main unit, yes, it passed or failed, and if it can go on to the next one. So parts cannot skip stations and cannot, so there's supervisor control throughout the cell. It also eliminates escape paths. The second half to that solution is data collection. And data collection has helped us quite a bit in the cells where this exists. We have reduced warranty claims. Previously, a warranty would come to our facility, warranty claim, and the most we could do is say, I'm sorry, here's a new part, without any data collection behind that. We also use this data for SBC purposes. Another big help was process drift. We have, for instance, dry test units. They would test the part to make sure there's no leaks. Well, a component within that dry test unit was slowly leaking. That data was being collected. Nobody was seeing that it was getting noticing the leak in their product, just as long as it fit within our scope. Well, pretty soon it started failing every single unit. So if we had process drift at that point, we would have been able to catch that and take it, replace it with it while on downtime instead of during peak production hours. And it also helped with paperless workflow, which I will get into in a later slide. And we can now accurately detect major problem areas. Solution 2 to our documentation. We needed to find a solution that we had reporting capabilities. So in each one of these documents, operators had to enter the same information on every one, such as shifts, what part they're running. Now this is all entered once. Reports are automatically updated, such as the hourly report. Every hour, they could see the new update without having to do any manual information. These reports, since none of them are sensitive, they are available throughout the plant. Anywhere you can get to a PC, you can get to these reports. So with these reports, just the three that we are currently replacing, over $2,000 per month per cell is saved. And with over 20 plus lines, this gives us $500,000 per year. These are one of our reports. This is just a snippet of it. You can see on the left is what failed, and on the above you see what was done to fix that. And then to the right of that is if it wasn't able to be fixed, it was scrapped, and why was it scrapped? Currently, this is this is one of them in our test phase, so operators had to enter these manually. But in our current setup, it is all done automatically. Here's the hourly report. This is the day by hour. This shows, so this is all entered automatically now, except for the reasons for interruptions. Operators still have to enter those. But you have the parts that were made, or excuse me, the goal that they had to meet, how many they actually built, and their current goal. So a few benefits that for this using this solution. One less operator is needed for doing those reports, putting those reports in Excel. That took about one operator per cell. So we saved the money of one less operator. We have employees called trainers. With coming up with these new documents, so many documents that have to be done, they became more document specialists. Now with this new solution, they are able to do their previous job as trainers. And as I mentioned before, warranty claims have dropped quite a bit within those cells. Manually reporting is dropping all the way throughout our entire plant as we continue to create these reports automatically. A couple benefits to the software itself. Ignition is a web-based system and quite easy to deploy. It's 15 minutes installation. You don't have to install it on multiple PCs. As long as these PCs, whatever it is, it's a tablet, it's anything that supports Java. If it can hit your server, then you have access to that software. It's not tag-based, which was big for me because starting this installation, I had no idea how many tags I needed. So I was going to buy a batch, and then after that happens, if I use them up, I have to buy another batch. And I'm not a fan of going back to my boss and saying, hey, I need more money. For something that we already purchased. So it's not tag-based, it's not client-based. You buy one license. That was a big plus for me. And some lessons learned. So before we purchased Ignition, we tried to make our own MES with a different software that was just like programming. So I had to program the entire thing. It was fine. It worked on one cell, but it didn't quite become an MES. It was more just a viscated solution. It never made it to an MES, and that was because I was the only engineering employee at the time. So we noticed we needed a whole team of people to complete that, and so it was not feasible. And a huge lesson learned was database-centric design. So it was built with and with Ignition, there's scripting, which is a great thing if you use it correctly. So It wasn't built with the database in mind. It was built more scripting in mind. So every time you added another cell, you had to add more scripting. So we stepped back, went back to the drawing board, and decided that let's look at the database. Let's have it where you just enter values in the database and you're done. So we use scripting to our advantage, and a big plus is indirect tags, which helped quite a bit. And to make this all work, just standardization. Obviously, if anybody has any experience with MES or EMI, standardization is key. So that is our experience with EMI at this current juncture. Thank you very much.